tomorrow, and then Wednesday you'll have a review. And as of right now, your quiz is on Thursday. Okay? So we're going over solving logarithmic equations today. So a logarithmic equation contains one or more logarithms. You can use the definition of a logarithm to help you solve logarithmic equations. So what we're going to do in order to solve a logarithmic equation is change it into an exponential first and then solve from there. I don't have a pencil.
I was gonna go get one. We're gonna go get one. That's what I was gonna do. I was gonna wait for it.
So we've solved exponential equations previously in our other sections. So to solve a logarithmic equation, we're just first going to change it into exponential. So our first example, we have log base 36 of x is equal to 3 over 2. Okay, so what I'm going to do is change this into an exponential by bringing in base 36 to both sides. Okay, when I bring in base 36, it cancels that log base 36 over on the left. So I have x is equal to 36 raised to the 3 halves power. Okay, so there are two different ways you could think about this. So one way, I could change my base 36, right, into 6 squared, because that's 36. And then I'd still have this 3 halves. And if I multiply those two exponents together, okay, I have 2 times 3 halves. Your 2's cancel out, and you're left with 6 to the 3rd. Okay, so that's one way. Another way, remember when we have a fraction as our exponent, that number on the bottom is your root. Okay, so instead of the 1/2 power, I can say this is the square root of 36 to the 3rd. Okay, so just changing that fraction into your root, okay, which would be 6 to the 3rd. Okay, so our x value is 6 cubed, which is equal to 216.
Doesn't matter which way we go.
No. We're going to do some other stuff today. All right, try example 2 then. It's very similar to the first example. Do example 2.
In text, like parentheses.
Do the last name of the author and
The question is like, do you double indexing? So like I say like Los Angeles Times report, and then at the end do I have to put it in parentheses?
Hey,
So then I would say like,
we should
Oh, I don't know. That's a question for your English teacher.
I know, and he's like, no question. September, fall.
Mm-hmm.
Like it'll be fall colors.
September.
Like beginning of September.
Will the would be like these. I would do it.
I don't know.
All right, so you should have first changed this into an exponential of x is equal to 16 raised to the 5/2 power. Then again, you could do this two different ways. I could change that base 16 to 4 squared raised to the 5/2. Or, since that half, again, makes it a root, okay, this could change into the square root of 16 to the 5th power. Okay, here, this one, your 2's cancel out, so you have 4 to the 5th. Here, square root of 16 is 4 to the 5th. So our x value would be 4 to the 5th, which is 1024. Okay, again, either way you think about it, if it was 5/3 instead, you'd have to take the cubed root of that number, okay, and then raise it to the 5th power. Okay, so remember that denominator in your fractional exponent there is your root. Questions on those two examples, solving that logarithmic equation? All right, so we have another property to solve logarithmic functions. So if b is a positive number other than 1, then log base b of x equals log base b of y if and only if x is equal to y. So if you see an equation where you have a log with the same base, okay, they'll cancel each other out and you can set x equal to y. Okay, so whatever's after it, it would equal each other. So an example, if I have log base 5 of x equals log base 5 of 8, then I can say x is equal to 8. So those log base 5's would just cancel each other out, and I could solve for x from there. Okay, so that's what we're going to do on the back here. Okay, so example 3, I have log base 2 of the quantity x squared minus 4 is equal to log base 2 of 3x. Okay, so since I have this same log base right here and right here, okay, if I would bring in that base 2, it would cancel out both right away. Okay, so if you have that same log base, what I can do then is say x squared minus 4 is equal to 3x. Okay, since I have an x squared and 3x, this is a quadratic, and you do need to get everything on one side of your equation. So I'm going to subtract 3x from both sides. So I would end up with x squared minus 3x minus 4 is equal to 0. Okay, what do I have to do from here? Do you remember? If it's a quadratic, what do I have to do? You have to factor. Okay, so I need to see what multiplies to negative 4 and adds to negative 3. It's not 2 and 2. Negative 4, positive 1. Okay, so that means this factors into x minus 4 times x plus 1. It's equal to 0. Okay, so I have x minus 4 equals 0 and x plus 1 equals 0. Okay, so I'm just taking each of those quantities, setting it equal to 0. So add 4 here, x would be equal to 4. Subtract 1 here, x is equal to negative 1. Now, since this is a logarithm, whatever is inside your parentheses here, okay, it cannot be 0 and it cannot be negative. Okay, so you do need to check both of your answers to make sure they work, because if it's 0 or if it's negative, it's not a solution. So first one I'm going to check is x is equal to 4. And you just have to plug it in to your original. So I would have log base 2 of 4 squared minus 4 is equal to log base 2 of 3 times 4. So I'm just plugging in 4 for each of those x values. So with this one, I'd have log base 2 of 16 minus 4 equals log base 2 of 12. Okay, so log base 2 of 12 is equal to log base 2 of 12. So since those are equal, they're both positive, that value works. Okay, next I want to check -1 to make sure that one works. So I'm going to plug in -1 for x. So I have log base 2 of -1 squared minus 4 equal to log base 2 of 3 times -1. Okay, so I have log base 2 of 1 minus 4 is equal to log base 2 of -3. Now I do get this to be log base 2 of -3 equals log base 2 of -3, but your value here cannot be negative. Okay, so if you end up with a negative in those parentheses, that is not one of your solutions. Okay, so it can't be negative. So I would cross out x is equal to -1. However, one of my solutions did work. That was when x was equal to 4. So I would circle that as my correct answer. Okay, so you do need to check both of your answers that you get. Questions? All right, then try example 4. It's the same process that we just did. Chapter 9.
No, she doesn't want me to finish it.
You only have to do sections 9-1 to 9-3, and it was a test.
Yeah, because I'm pretty sure each one is like A, B, C, D, E, A, B, C, D, E, A, B, C, D, E.
Gotcha.
So I got 80 on it because I left 4 questions blank. I left 4 questions blank and it was 5 points. But I mean, considering that's 100% percentage of the ones I did.
Yeah, that's pretty good.
I know, so whatever.
I wouldn't be upset about that.
No, I'm just upset that I could have got 100. What is that? Did you just hear a fire drill?
We need practice. Well, yeah, that's why you practice.
Are you going to Stevens play?
Hmm?
Are you going to Stevens play?
No, I just played football there for a little bit.
Guys, do this problem. Put the ball away. You don't need to. I don't care. Do this problem.
Is it still raining outside?
I believe so.
It is raining.
I don't know. I have no windows in the room.
Okay.
I mean, it was raining during last hour.
Lisa's supposed to be rubber so good.
Did you want to see if you got it right?
Yeah, kind of. Wow. Close enough.
I
You should get 5 and -3.
Alright, that's what I got. I just haven't checked it yet.
Yep. Okay, so I do want to go over example 4. So here you should have set x squared minus 15 equal to 2x. Since you have the same log base, those cancel out. So I have x squared minus 2x minus 15 equal to 0. From here you do want to factor that. So you want to see what multiplies to get negative 15 and adds to get negative 2. Okay, that is negative 5 and positive 3. So I would factor this into x minus 5 times x plus 3 equals 0. Set both of those quantities equal to 0, so x minus 5 equals 0 and x plus 3 equals 0. So I have an x value equal to 5 and x equal to negative 3. Now, you do need to check both of those answers. So first checking x is equal to 5. I would have log base 3 of 5 squared minus 15 equal to log base 3 of 2 times 5. And I do end up with log base 3 of 10 equal to log base 3 of 10. Okay, so that one works, and x equals 5 is one of my answers. Okay, also plugging in negative 3 for x. So we have log base 3 of negative 3 squared minus 15 equal to log base 3 of 2 times negative 3. So we end up with log base 3 of negative 6 is equal to log base 3 of negative 6. And again, these two answers right here should not be negative. Okay, they should not be 0, they should not be negative, so this one does not work. And your only answer would be x is equal to 5. Now, sometimes your negative answers do work. Okay, don't just take this as if I get x to be a negative number, it won't work. Sometimes they do work. There's an example on your practice sheet where -1 might work. Okay, so you do need to check to make sure. Questions on example 4? All right, then last example here. This one's pretty similar to the ones we did on the front. So again, we're solving this logarithmic equation. And first, what we want to do is change it to an exponential.
We just need plastic water bottles.
Oh, okay.
No?
That's, no.
Does anyone want to finish their water quick? Hey, who has a plastic water bottle in front? Is that Seth?
Eric.
Oh, Eric.
Just take it and just throw it
Both
away.
got one.
Can you give me water bottle? Can you use your water bottle?
Just throw it away. Or just empty it out. You won't care.
You want to chug it?
All right, so I want to change this to an exponential. So since my base value is x, I'm going to bring in a base x to both sides. Okay, when I do that, these two cancel, and I'm left with 32 is equal to x to the 5/2 power. All right, so now to get x by itself, quiet. To get x by itself, since it's raised to this 5/2 power, I'm going to raise that to the 2/5 power. So I'm going to raise it to its reciprocal. Okay, same thing on the other side then. So whatever I do to one side, I have to do to the other side. Okay, so on the right side then, your exponents will cancel each other out and you're left with just x. But you have this 32 to the 2/5 power is equal to x. Now that 1/5 or that 2/5, you'd have a 5th root of 32. So again, two ways you can do this. So I can separate this and find a different base for 32. Okay, so I would use base 2. Okay, and 32 is 2 raised to the 5th power. And that's still raised to the 2/5 power. Or I could say this is the 5th root of 32, and that's squared. Okay, so whatever's in the denominator of that fractional exponent, that's your root. Now, since I have 2 to the 5th power, I can multiply my exponents. When I do that, my 5's cancel, so I end up with 2 squared. Okay, same thing over here. If I take the 5th root of 32, it is 2, and that's squared. So our x value then is going to be 4. So again, either way you want to think about it, if you do have x raised to that fractional exponent, you just raise that to its reciprocal on both sides in order to solve. Okay, any questions on that last example?